Okay, it's fabulous to see the great crowd of people who are here and all the ones who are online as well. And welcome everybody. Delightful. So tonight I have a two-part talk. The first part is about our foray to what we always call Cooloollah, but in fact it is the Lake Cooroibah section of Great Sandy National Park, which we do every year and have done for the last 11 years. The rangers say to us, why do you want to keep coming back here? And we say, because we keep finding new fungi. Every year we find new fungi. So that's why we keep going back. And so let's start with our first slide, please. Okay, so we gather on the Saturday morning, and this year, Tammy brought her little travelling laboratory, which was really interesting because she has a microscope that can be used out in the bush, and we were able to look at a few things under the microscope, and that's really quite a bit of a treat when you're out in the field. Okay, so we gather, then we scatter all over the place looking for things, and finally we assemble, and that's the group that went on the foray this year. Lots of keen eyes, and it was a good day. We'd had some rain, which was fortunate because it's tended to be a pretty dry year this year, but there'd been rain just a few days before, so there were quite a lot of fungi out. Next. Altogether, we found 23 different species and made 18 collections. And of those, 13 of them were agarics, that is gill fungi, and the breakdown is there. 5 were boletes and 4 polypores and a piezolythus. So a reasonable spread of fungi in the area. I'm going to start by just going through the Amanitas that we found, although we'll come back to some of them later. The first one was one with a margin that was striate. Now, I wish I had a pointer, but we don't have a pointer, do we? You've got a cursor? Okay, so you can it has a striate margin. It's not very obvious in that that slide, but never mind. No annulus or ring, which you can see on the left there, and a big sac as a vulva at the base of the stem. And the spores were inamyloid, which means that they didn't stain when I used the iodine solution Meltzer's. So that one was the first one we found. Next slide. Interestingly, I think it was the same as one we found last year, which happens occasionally. No annulus, saccate vulva, and a margin that is striate. Unfortunately, you can't see that terribly well on those slides, but it is there. And the spores were a little bit different, a little bit smaller in this one, but I think probably it was the same species. Next one. This was a really beautiful one that was a singleton. We only had one specimen of that, a silvery grey cap, and the margin was really shaggy, and that's called appendiculate. The annulus was what's called fugacious, and that means that it was just fleeting, it was disappearing, and unfortunately, as happens sometimes, the base of the stem had been destroyed as it was being collected. So, lesson learned. The spores were amyloid, that is, they went dark blue when we put Meltzer's on, and unusually for Amanitas, they were these elongate shape. And so that one is possibly elongata spora, as in fungi of Queensland, and we'll come back to fungi of Queensland later on. But it's possibly that, although it may not be. Next. So the next one had a smooth grey-brown cap and very finely appendiculate margin, which you can see on the left one. And all of these need to be looked at when the fungi are first found, when they're fresh, and otherwise it tends to dry out and you don't notice them so much. It also had a saccate vulva and not quite as big a sac as the last one. And the spores were strongly amyloid and round in shape. Okay, next one. Another one which was just a singleton, a little one this time, but a beautiful glossy brown cap and very little in the way of remnants on the cap. You can see a little bit on the left-hand fruit body, just a few little specks of the veil there. And the margin wasn't shaggy, it wasn't appendiculate. And it had a very felty, thick annulus, which was quite high up on the stem. And the bulb at the base of the stem was subglobose. So these ones had amyloid spores. And again, it's possibly basibulbosa, which was one that Patrick described in Fungi Queensland. Okay, next one. This one that had a golden brown cap with no remnants on the surface. And the margin you can see on the left-hand fruit body was appendiculate. There were just bits hanging off it. The annulus was quite thick and striate. It was like striped. And the bulb at the base was a rather irregular shape, but sort of ovoid. And it had quite small spores, which were amyloid. Okay, next. This one, which was a little bit maggoty, had a steel grey cap. Oops, that one. And it was smooth, but it had some white velar patches, which you can see in the smaller one and also in that one on the left. And the margin was finely appendiculate. It didn't have any annulus, but the young ones had a cortina-like veil, which is a bit like a cortinarius. And the bulb at the bottom the base was just slightly bulbous. If you look at this little one on the right-hand side, that's what an amanita looks like when it hasn't yet opened at all. It's still covered in the universal veil. And these spores, again, are amyloid spores and subglobose. And this one we know quite well from Coolooloo. We've had it many years, and that's one we call Amanita afrubescens. It is not the Northern Hemisphere rubescens. It looks somewhat similar, and it has this reddish stem, an annulus that is white on top, but it's red underneath, or brownish red, and the cap is covered with these scales. But in 2018, when we found the same species, it had been raining and the rain had completely washed off all of those scales and changed the colour of the cap to that reddish brown. So the characteristics of the species, different species, can change due to weather. Okay. So that was the Amanitas. Then we had a number of boletes, and this one was fascinating because, although it was a little bit tatty, it had a purplish apex to the very thick stem, and that was the same in both specimens of the or both fruit bodies of that specimen. And the gills, not the gills, the pores were this pale buffy pink colour. And it didn't stain at all when it was cut. So a boletus maybe, don't know what kind. Okay, next. This was a very beautiful one, which with its red and orangey coloured cap and the deep yellow, very large pores. It may be in the Rubinoboletus balui group, and that was probably about as far as we could get with that one. Next. And this was another one which was equally beautiful, quite small, and had a very smooth cap and the very large and coarse pores underneath. Patrick spent a long time looking at that and trying to see what he could make of it, and he, in the end, thought it could well be a Chalciporus afarantiacus. I can't argue with that. I don't know anything about it. So that was what he came up with. Next. And then we had another Boletus. It could possibly be the same as the first one, except that the stem was not purplish at the top of it. And so I don't know if that's a significant feature or not. Certainly the pores were very similar and the tubes were that buff pink colour, and it didn't stain when it was cut. So it may perhaps be the same species, but it may not be. This was one that we felt we did know, and with the beautiful reticulate stem on the left, you can see that network on the stem puts it into the Ostroboletus group, and having a white cap and this pale pinkish sort of pore surface, it is probably Ostroboletus niveus. And so it was nice to see that one. I don't think we've ever found that one before at Cooroibah, but we have found other Ostroboletus there. So nice to have one of that genus in the group. And this is just taking you back to last year, because sometimes it takes a long time for people to work out exactly what something is. And we found this tiny little psicotioid. That means it wasn't really emerging from the ground. It was just sitting on the ground, little bolete. And it was beautiful pink, and it had this bright yellow, tiny little stem. So the whole thing was no bigger than about the size of a 20-cent piece. And the spores were bean-shaped. So again, Patrick had been working on that one and thought it was Tylobolus, but didn't have anything further until he read a paper recently by Wolf and Bouger, 1993. They described Tylobolus queenslandianus, and he thinks that this fits with that. So nice to have an ID on that one. That was from last year. Okay, so we also found a few Leucaria, and Leucaria, some of you will know, tend to have flesh-coloured gills. Well, this was a pretty dark flesh, but nevertheless, they were Leucaria species. There are many Leucaria species, and most of them we don't have names for. Okay. We found one little inocybe, which are the fibre caps. And you can see in the top right-hand one how fibrous the cap looks when it's close up. Often that is so well pressed down or it's been rained on and you don't see them so clearly. Inocybe can have smooth spores, or they can have quite warty-looking spores, but this happened to be one with the smooth spores. Next. We hoped that we may be able to find an identification for this resupinate, meaning it's completely flat polypore. It was growing on a very burnt log, and you can see on the right-hand side the charcoal and the fruit body actually coming straight off and very adherent to the charcoal. But we asked our we'll come back to the questions later, or the comments. We asked our expert, Matt Barrett, in Cairns if he knew that one at all, or could recommend, or, you know, give it any identification, and he couldn't. So it remains a resupinate polypore on a burnt log. Okay. But we did find a couple of polypores that we know well. The one on the left, of course, the orange one, is the ever-present Pycnoporus coctineus. And the one on the right is the Phaeotrametes decipiens, which is a really beautiful one that we've only ever found growing on dead Alocasuarina branches. And it has this lovely brown velvety upper surface. And underneath, it's basically white, sometimes almost lavender, and very large pores for quite a small fruit body. So nice to find old friends. So then we also found one of the horse dung fungi, the Piezolythus, which of course means peas in stone, Piezolythus, peas in stone. And this one is Marmaratus, which is marbled, and it's the marbled horse dung fungus, we think. Quite a beautiful thing when you cut it. And that was the highlights of our foray. But I just want to do a plug now for anyone who's interested in boletes. It's just a fungi map alert that on Thursday of next week, Pam O'Sullivan from New South Wales is going to be doing a Zoom lecture on the Boletaceae family in Australia, and looking at how to identify some of them. So if you're a member of FungiMap, you can certainly join in, and if you aren't, it's worth joining FungiMap anyway, and then it's a freebie. So just a little ad. So then I want to move on now to looking at the Amanitas in more depth, mostly of the Great Sandy National Park Cooloollah hotspot, but also in general, southeast Queensland. We have a lot of Amanitas here, and we don't have a lot of knowledge about their identification. So it's a bit of a challenging genus, and yet there are wonderful characters which are quite clear and obvious and plentiful. And sometimes when they're recorded carefully and followed through, you may get to an identification, but it needs some people to do the work. And I'm busy doing Marasmius, but I'd love somebody to take this on. We'll come back to that later. So in southeast Queensland, where do they grow? Well, they grow in wet and dry sclerophyll forests, in the Wallam woodland particularly. They'll grow in any soil, but they seem to be particularly rich in the sandy soils. And you have to look at what are their mycorrhizal associates, because the ones that we find here generally are mycorrhizal, and they're mycorrhizal with eucalypts, melaleucas, Alocasuarinas, and they seem to be prolific in the Wallam woodland areas. So the hotspots include the Great Sandy National Park, Noosa, Gari, Maritchi Bushland Botanic Gardens, as well as up in the hills, Linda Garrett and Mapleton National Parks. And then if you go further inland, Girraween is another hotspot. But you don't have to go that far to find a lot that are growing in our area, particularly, say, from, I mean, they'll grow everywhere, but from Bribie Island up to, and somebody was talking tonight about Stradbroke. So go a bit further south, Stradbroke Island, all the way up to Fraser Island. There's a lot of good spots for Amanitas. We have no idea how many species there are in that area, but there are 49 of them recorded in Fungi of Queensland. Now that's a work that mostly Patrick has been doing over a number of years, trying to document everything that comes up and trying to put a name on things. And he's been working with a very old key from Alec Wood, which was done in 1997. It's a very difficult key to work with. And so he's done his best on those. So it's 49 different ones in Fungi of Queensland. And that we've recorded 23 species from Cooroibah in the last 11 years. And that's just going for one morning once a year. So who knows how many others are there. And of those 23, we've been able to name 5 with reasonable certainty and another 4 possibly, and that leaves at least 14, probably more, unnamed. And in Fungi of Queensland, Patrick's given 42 out of the 49 names, but with lots of caveats, saying, you know, that it appears to fit with this identification from Wood, but not in this, and this characters. So, you know, there's a lot of caveats, and none of them have been done with the addition of DNA. So what tools do we have for identifying these things? There is that Alec Wood monograph from 1997. And Derek Reed, he described a number of Amanitas. We have our field guides, and that was interesting. I went through them yesterday just to see how many Amanitas are in our field guides. Interestingly, the Tasmanian one has 15 Amanitas in it, which is a lot in a field guide. Unfortunately, quite a number of them are only Southern Australian and don't occur up here. And Bruce Fura's field guide has probably about 6 or so, most of which are the really obvious ones. And so the field guides give you just a hint of what's around, but don't help you with the ones that are much less pretty or obvious. Okay. So I have to thank somebody for all the information that I have pulled together for this talk, and that's Elaine Davison, Professor or Dr. Elaine Davison from Western Australia, who has worked with Amanitas for many years, and she kindly gave me a lot of notes and her presentations, and so I've drawn heavily on them for the rest of this talk. So first of all, there are some things that I hadn't really realised, and that is that although we're used to seeing Amanitas as mushrooms, that is epigeous, that is above ground, they do also occur as sequestrate or sequoioid fungi where they've got well-developed stems, but the caps don't open, and they're at ground level and they're not opening. And they do also occur as sequestrate hypogeous fungi, which are the truffle-like ones, and there's no obvious stipe in those. And those second two, or second and third, I've never looked for, I have to admit, and we've never found here in Queensland, but I'm sure they do exist. Just reminding everybody what the structure of an Amanita consists of. There's first of all the early developmental egg, and that has a universal veil which goes right around, protecting the whole thing, as you can see in this bottom photo. And as well as the universal veil, there's a partial veil, which is here on the left in number 2, and that protects the gills. No, sorry, this one here. Number 2, partial veil, which protects the gills. And as the mushroom grows and expands, those things break apart. And so the universal veil can disappear completely from the top, which is number 3 up there, or it may be left as little remnants. And they can take lots of different forms. At the base of the mushroom, the universal veil can be just left as tiny weeny remnants, or maybe actually a big sock, and it's called a saccate volva. The partial veil breaks off as the cap expands and leaves an annulus, or it may leave almost nothing, or it may leave shaggy bits on the edge of the cap. Okay, so that's the anatomy of it. And there's lots of variations, which we'll now look at. So first of all, in doing the descriptions, which I've actually done a list up, and people, if anybody wants to get into doing this, can take a copy of this afterwards. So it's basically what's up there as we go through. First of all, measurements. We need to measure the size of the pileus. We later on need to measure the stem and also the bulb if there is one at the bottom. Checking for the colour. And the colours can be really varied from white through to orange, brown, red, pink, grey, green even. I don't think there are any blue ones. So the pileus colour may change when it's bruised, or it may change with rain, as we saw in that earlier photo. And then we need to always carefully look at the pileus margin. It may be sulcate, which means like it's pleated. Now, what you're seeing there mostly are the gills underneath. I'm sorry, but the photo hasn't come up clearly enough to really show the sulky, but it is sulcate there. It may be smooth. The cap margin may be smooth, or it may have this shaggy appearance, which is called appendiculate, or it may be not smooth, but just not appendiculate. Okay, next. And then thinking about that universal veil on the pileus or on the cap and how it has broken up, there may be nothing left. So it can be absent, as in that beautiful orange one, or in the brown one, there are no remnants there, just a bit of dirt. Or it may have formed membranous patches on the cap, or thin flat scales. There may be little felty patches. You can just see these are very easily brushed off when you're getting rid of the dirt. So you have to be really careful when you're collecting it. That may form soft warts, and they can be different colours. Those first two on the bottom row are the same species, but they just look quite different because of the colours. And remember, they can all get washed off with rain. Again, it's a bit hard to see this one, unfortunately, but it has straight-sided and flat-topped warts. And then there are pointy ones, pointy warts, which may be like the one at the top, or these softer pointed warts. Okay. And you need to know how well attached those remnants are. They may be adnate and firmly attached, or they may be easily removed, and you can see that they're falling off onto the leaves underneath. Again, when you're collecting them, you need to be careful to not just clutch onto the cap and destroy all that remnant. Down the bottom, go back. This is something that I always forget to do, and that's to smell the thing. And in Marasmius, it's not usually a feature, but in Amanitas it can be. There may be no smell, but there may be a mushroomy smell. It could be sweet, it could be farinaceous, which I think is sort of like cereal or flour. Is that right? No, something like that. It can be quite chemical or rather unpleasant. So don't forget to smell the thing. Okay, next. Then you need to note the colour, and it's sometimes we rely entirely on photos, but photos don't always give us accurate colours. I know if Stephen's taking them, they're always accurate, but he would know the challenges of getting an accurate colour photos. But so it's good to actually write down what colour it is, if it's white or if it's cream or pink. If it's white and bruises red, which you can see there from insect attack probably mostly, or if it's an ochreish colour. The one that I hadn't realised before, and this is a photo from Elaine, is that occasionally the cap margin can be, the gill margin can be a different colour from the gill face. And that wasn't something that I knew could happen in Amanitas, but it needs to be noted and looked for. Okay. Then moving down, we're going on to the stipe or stem, and they can be various colours, which you can see here. And then it's important to comment on the surface texture, because that can be smooth or it can have a zigzag sort of pattern on it, a zebra-like pattern. This one is actually reticulate, which is like a network there, or it can just look soft and fibrous and does a stipe change colour when you bruise it. Okay. So having looked at a universal veil on the top, we're moving down and we're now looking at that partial veil, which forms the annulus. And it may be absent, and this one up the top has nothing left. It's disappeared completely. Or it may be present and it may take various forms. And it can be membranous, like a little bit of soft cloth. It can be thick and felted. It can be a bit like a spider's web. I didn't have a good photo for that. But fugacious, which means it's sort of fleeting and it can disappear, and if you touch it, it's liable to just break off. This one down the bottom that's fugacious as well has lost most of its content. The other thing that I hadn't really thought about before was, where does that break as the cap expand? And it can break right at the edge of the pileus, and you can see it breaking off there on that one. And then it forms quite a long annulus, and or it can break in the middle of the veil, and then you're left with those bits hanging off the edge of the cap, as well as the potential for some being a ring or an annulus. So you've got both of those. Okay. So then another thing that I hadn't really taken a lot of notice of was, where does the veil sit? It can be apical, right at the top of the stem, abutting the gills, or it can be superior, which is high up but not apical, middle of the thing, median, or inferior. And there's one particular species that we have had at Cooroibah, which is diagnosable, it's identifiable is the word, because it actually has a double annulus, and that's Amanita ochrophila. And I'm not quite sure how that comes about, because you've got a membranous annulus at the top and this other one lower down. I'm not sure how it happened, where it was attached. So other experts may be able to help me there later. Okay, next. So then, again, this is something that needs to be recorded, and because often things fall off when you're carrying them home. So record the colour. It can be white, it might be a yellow or a pink or white with reddish brown underneath. This was one we found last year, and it had a grey annulus, but it had a darker margin on it, and not one that I've seen before with that sort of configuration. Okay. Then moving right down to the bottom, the universal veil at the stipe base, which may be absent, as in the left-hand one. It may just form a very fragile limb, which is very easy to leave behind when you're digging it out. Or it may form warts or scales or ridges or bands. Or it may also form a beautiful sock, which is a saccate vulva. And that one also can get left behind really easily. And you need to look at the colour of those things too. Okay. So then, having looked at the outside part of the base, we need to actually look at the shape of the stem at the bottom, which may be just straight, and the bulb may be absent. You can see this one in here. It just goes straight down and has no enlargement at the bottom. but it may take a number of different shapes. I love these names. Clavate, which means club-shaped. Just generally, you know, one of those things that the Stone Age people bash you over the head with. It may be. This one was irregular. They didn't actually have that name in the options, but it was irregular and it was sort of oval. Then the next one is, maybe it's turbinate, which means top-like, like a spinning top. And napiform, I discovered, means turnip-shaped. Now, I don't know if a turnip looks like that or not, but that was the closest that I could get to that shape. And the next one is conic or carrot-shaped. I like that. Conic does not mean carrot, but somebody thought, well, it doesn't look all that conical, so we'll call it like a carrot. Fusiform is like a spindle shape. So it's narrow at the top and then narrow again at the bottom. And then a globose or subglobose is almost spherical. Okay, so lots of different shapes. And if people are describing these, if you've got very good photos, particularly if they've been cut in half lengthwise, then that's often sufficient. But if you're writing them, you've got to have some words to use, and you can use plain English. You don't have to remember all these for these names, but they're fun. And the last thing that you need to do is to get a spore print. And it's really important with Amanitas to try and get a spore print and to try and get it onto a glass slide, at least some of it onto a glass slide, so that you can put a drop of this iodine solution called Meltzer's on it and see whether it goes a dark blackish blue, which is on the right-hand side, and that's called amyloid, or it does nothing, and so it just takes on a little bit of the colour of the orangey brown Meltzer's and it stays a yellowy colour. In amyloid is its technical term. Those two differences are really important in working out what Amanita you've got. Okay, so this is where we start to think, well, we've got all these characters. Can we get any identification? Well, you can probably get to section. You may get a bit further than that, but it does require quite a bit of work, and some of it has to be microscopic work. And then, of course, today, there's all the DNA that it needs to be added as well. This paper, a lot of this is thanks to Elaine here, but the paper written by Cooroibah et al. In 2018 has suggested that, okay, we have the genus Amanita and 3 subgenera. At one stage recently, the one on the left was taken out of Amanita altogether, and it was called, what was it called? Saproamanita, because it's actually not mycorrhizal. Oh, hello. That's something new. I didn't know about that. But others said, look, they are still all within the same group. So why separate it out and call it another genus? Keep it there, call it a subgenus. It can be Lepidella. They have amyloid spores. They're saprophytic, not mycorrhizal. So the next two are the subgenera that are more commonly occurring here and that we'll look at a little bit more closely. So one has amyloid spores and the other has inamyloid spores. Both of them are mycorrhizal. Okay, next. Now, too far, go back. So the subgenus Lepidella, Amanita nauseosa, the one with an awful smell and a very flowery cover, which I believe occurs here in Queensland, is an example of the subgenus Lepidella, and that's about all I'm going to say about that one. Okay, so we go to the subgenus Amanitina, which is very common in Australia, and it has a type which is Amanita phalloides, would you believe? You know, that dreadful thing called a death cap. But the subgenus is common in Australia, and most of them are mushroom-like. So, okay, so we're in the subgenus Amanitina, and there are 6 sections in that, 2 of which may or may not even occur in Australia. So that's section Amidella and Strobiliformes. And so I'm not going to even talk about those 2. And the one in the middle of that graph is one that is known only from southern Australia, and it's considered to be a Gondwanan group. So just concentrating on the one on the left, which is section Rhonokenses, and it's probably the most numerous section in Australia. I'd never heard of it before, so we are all learning here. And examples of that are Amanita ochrophylla and Amanita pyridemifera, and that one from Cooroibah with the beautiful appendiculate margin. Now, what makes something in section Rhonokenses? Of course, the spores are amyloid. The spores are all amyloid in this subgenus. They're amyloid, and the pileus margin is not striate, but it's appendiculate, and the stipe has a bulbous base. And the velar remains on the cap are varied, and the annulus is either membranous to fugacious. So those features suggest that something is in section Rhonokenses. Then the section in the middle, which is probably only known from southern Australia, may not be present up here, although Amanita peltigera is one of that group, and something very similar to that has been described in the fungi of Queensland, so I don't know if it does occur this far. Then section Phalloideae, which is the Amanita phalloides group. A lot of those are more southerly. We don't get phalloides in Queensland, thank you very much. That's because we don't have the oak trees here. But again, the spores are amyloid. And I won't go any further with that one because I want to focus on the one on the right, the section Validae, and Amanita flavella and Amanita luteolobulata are members of that group. The spores, again, are amyloid, as they all are in this group, and the margin is non-striate, but it is not appendiculate. And the stipe base is either globose to subglobose, and the annulus is membranous. And some of those bruise red. So perhaps our aphrubescens that we were looking at earlier could be in this section. Okay, next one. And that just goes through the ones that are examples. Amanita ochrophylla and pyramidifera in the Rhonokenses, as well as that Amanita species Cooroibah, I've called it. And then peltigera in the central one. Amanita phalloides, which doesn't occur in Queensland, in the Phalloideae, and Amanita flavella and luteolobulata in section Validae. Okay, then moving on to the subgenus Amanita, it has 4 sections. Again, the section on the left is only known from Australia and South America, and again, it's Gondwanan. And it may or may not occur in Queensland. I'm not sure. Umbranella is a group. It's not just a single species. We may have members of that group here. But looking at the other 3 sections, there's section Amanita, and the type for that is Muscaria. We all know the red Amanita with white spots on it. But for us, the other example is Amanita xanthocephala, which is that yellow one there. And the spores in this whole group are inamyloid. So they're inamyloid in this whole group, all of that subgenus. And the pileus in the section Amanita has got persistent velar remains on the top. So there's little bits of the universal veil there. And the margin of all of these is striate. And that means that the flesh is thin and you can actually see the gills through the edge of the cap. And conversely, in the other section, the other subgenus rather, where they're non-striate, the flesh is thicker and you can't see the gills through it. And so that's why it's non-striate. That's something I hadn't really thought about before, although it occurs in Marasmius, but I hadn't thought about it for Amanitas. So then the section Vaginatae, again, the spores are in amyloid. And there's another feature, which is microscopic clamp connections are absent. And the pileus margin is often sulcate, as well as being striate. That's sort of almost pleated. And you often see on Facebook, someone will put up an Amanita and say, what species is this? And the experts will come back and say, oh, it's an Amanita section Vaginatae. And that's because of those sulcate striate margin to the cap. And all of that group have striate margins. So I think you have to be a little bit careful in making that identification. The velar remnants are usually absent, but not always. There's a big patch on that one. The stipe base doesn't have a bulb, and it may or may not have a saccate vulva. The annulus is mostly absent, but occasionally it's there. So I went through that one, and then the next one, section Caesariae, and the type is Amanita caesarea. Well, that's pretty obvious. But in Australia, Amanita roseo-lamellata, the pink-gilled one, Amanita egregia, and the Amanita hemibaffa group. And that photo I took up in North Queensland of one of the hemibaffa group, or several of the hemibaffa group. So the spores there are in amyloid, as always, in this whole subgenus, and it does have clamp connections. That's microscopic stuff. The margin is striate. The stipe doesn't have a bulb, but it has a saccate vulva, and it has an annulus. So the differences between the Vaginatae and the Caesariae are fairly subtle. The annulus, mostly absent in Vaginatae, present in Caesariae. This microscopic feature of clamp connections is absent in Vaginatae and it's present in Caesariae. So it may not help too much in the field. But, okay, so go to the next slide. So that's just giving you the examples from Australia that we've got, just to remind you of which ones are in which section. So while this doesn't help or take you to a species, it does help getting to various sections. What I've done is actually put this all in a sheet, and also the PowerPoint will be available on our website. So if anybody wants to make use of this information, because it's a lot to take in one hit, then it will become available for people to use. The next slide, thanks. Just recapping there, when you're collecting, always take as many photos of different angles showing the fungus in situ, and then digging it out really carefully and taking more photos to show the gills and the stem and the annulus, making sure that you actually see whether it has a bulb or doesn't have a bulb, whether it has a vulva or not. And note the habitat, because we need to learn more about what are the mycorrhizal associated trees. Make sure that the whole specimen is cut in half, and that is something that perhaps could be done when you get home, so that it can be done really carefully with a very sharp knife and can show all of those features. And then make sure that there is a spore print done if at all possible. And then I've listed the macro characters that we look for. So I think that this is a project that somebody could take on. It perhaps could be done as a citizen scientist, just somebody saying, I will walk that park every day after we have rain for, you know, for a week after this rain, every time there's rain in the over a year or two, and collect these when they're at their best, as opposed to when we go once a year, one day, maybe a week after rain, some of the fruit bodies have already become maggoty or half dead, and we don't necessarily get at the best. It needs somebody to actually know at the times, and to use all these helpful hints about how to make the collection and what to note when you're doing it, and what photos to take, and how to get a spore print. And then really, I think that it would be a great project for somebody doing honours or doing a master's, comparing this section with some of the other Wallen woodlands, and trying to get an understanding of the biodiversity, of the Amanita biodiversity of Southeast Queensland. So really, hopefully, these will be helpful, and hopefully it's a challenge that some students can take on and run with. It's not something that I can do as well as doing Marasmius. But so are there any questions? And the question is, what makes an Amanita an Amanita? And the answer to that is so technical that I just glossed over it. It's really microscopic structures, and really blah. It left me sort of going, that doesn't help me at all. So sometimes it's a bit of a you get a feel for what's an Amanita, and they often have an annulus, not always. They often have bulbous bases, not always. They often have vulval remains, not always. But you get a feel for the overall thing. I just wonder if Nigel might be able to help us with this. Okay, I'll just have to say this to the people who are online. Nigel, who's our expert here at the herbarium, says it's really difficult to give a specific group of characters because it's such a big set. And yeah, yes, yeah, yeah, yeah. So that's the Nigel to talk about how they're usually mycorrhizal. It's not easy to find something in the woods or in the woodland and say, oh, this is mycorrhizal because it's here, because we also have things that are not mycorrhizal occurring there too. And sometimes mycorrhizal things might be growing on wood, whereas normally we expect them to be growing in the soil close to the trees that they connect with. So again, yeah. Not always easy. Okay, next question. I can't read it.
Thanks, everyone. And thanks for coming along.